In this question, 3-point charges capital Q, small q and minus small q are kept at the vertices of an equilateral triangle of side L as shown in the figure. We have to find the electric potential energy of the arrangement and the potential at point D. So let's understand the first part of the question. In this, we have to find the electric potential. So as the figure, it's the equilateral triangle. So if we draw the equilateral triangle of same length, so this is L, L and L. We name it as this point is A, B and C. So at A, the charge is capital Q. At B, charge is minus small q and C it is plus small q. We have to find the potential energy of the system. So we know that potential of a charge is equal to K, Q1, Q2 by R. So if you have to find the total potential, it is equal to the potential of AB plus potential of BC plus potential of CA. And if we substitute the value, it is K, QA, QB by length is L plus K, QB, QC, again the same length L plus K, QC, QA by L. So for the K we can take common and L also we can take common. So we get QA, QA is capital Q, QB is minus Q, plus QB is again minus Q, QC is plus Q and QC is plus Q, QA is capital Q. So you see that here these two can be cancelled. So total potential energy can be written as K by L into minus Q square, or further we can write it as 1 by 4 pi epsilon naught L, here minus Q square. This is the answer of the first part of the question. In the second part of the question, we have to find the electric potential at the point D. So here if we draw the figure, we have already known that we have an equilateral triangle. This is equilateral triangle, and at this point we have a D. So this we can join it as here D. This is A, B and C, capital Q, minus Q, plus Q. And the length of the DC is L by 2, means it's present at the midpoint. So this is also L by 2. First we have to find the distance of AD. So this is 90 degree. So what we can do, we can use the Pythagoras theorem. So by applying Pythagoras theorem, we can say that AC square is equal to AD square plus CD square. AC square is L square, AD square we have to find, and CD square is L by 2 whole square. So AD square is equal to L square minus L square by 4. It's equal to 3L square by 4. So AD is equal to root 3 L by 2. So we got the value of AD. Now we can use the potential formula. So V is equal to K Q by R. This is the formula of a potential. So here potential at point D is equal to the potential due to A plus potential due to B plus potential due to C, or here we can put D also. So now potential of AD is equal to K, charge of A is how much? Capital Q. So Q by distance is AD distance we got just now, root 3 L by 2. So we can write it as 2K capital Q by root 3 L. Now here in the second part BD. B has minus q charge, so we can write k minus q, and the length is L by 2. So we can write it as minus 2k q by L plus CD. CD is plus q charge, so k into plus q divided by length is same, L by 2. So it's equal to 2kq by L. So now as you see, these two are exactly same, so we can cancel it out. Vd is equal to 2kq by root 3L. It can be also written as 1 by 4 pi epsilon naught q into root 3L. So this is the answer of the second